All right, so we are going to work on 1.4, which is going to be graphing linear equations in 3 variables. But before we do that, we're just going to have to get some basics here about what it's going to look like in 3 variables and just like how the equations just are going to appear. And then we also just have to get some basics about our new coordinate system that we'll be working with for the next section, basically, or so. Okay, so within this lesson, we have one learning target, and that's just so that you're going to be able to graph linear equations in 3 variables. So solutions to equations in 3 variables can be pictured with a 3-dimensional, so I'm just going to put 3D coordinate system. Okay, and within that 3 coordinate system, to be able to construct this system, basically what you're going to do is you're going to take like that regular horizontal like XY coordinate system, which would just be like a plane, like a sheet of paper. And what you're going to do is you're just going to try to place it flat, and then you're going to have basically a vertical line coming out of it. So you'll have like the XY coordinate system, if this lay flat, then you'll have a vertical axis coming straight out of it. Okay, and then that is what we're going to be considering called the z-axis. Okay, so now there's a 3rd variable, generic variable that we're going to introduce here, and that's just the z variable. And each point in space, so like I can pick any point in the space that I want in this system that I've created, and it's instead of an ordered pair, it's an ordered triple. Okay, and in the order X, Y, Z, which is alphabetical order, and those can really just be any kind of number you'd like to see. Okay, and then finally a linear equation in 3 variables. X, Y, and Z is in the equation AX plus by plus cz is equal to d, where a, b, and c and d are just numbers basically of any sort, any real number, I should say, I suppose. And that the graph of the linear equation in 3 variables is indeed a plane. Okay, so a plane we have discussed in geometry classes, but it's like a floating sheet of paper that extends out in all directions. So it could be floating like this, like this, like this. It can be sitting however it wants in space, and everything that lies on that infinitely small sheet of paper is a solution. Okay, so let's just kind of get the basics of what this might look like. Okay, so these can often be kind of difficult to show in on paper. So I will, maybe after this video, I'll make another one that kind of explains some of the, or just can show like what a computer would generate to maybe look like. But for the most part, let's just look at our coordinate system. So here you can see with the little grid, it's got a little grid laid out for you. That's our XY coordinate system. So just like any other graph that you've dealt with in the past, we've just taken that and we've just flattened it out. Okay, we flattened it out, and then we have the z-axis here. So they do have little labels here: x-axis, y-axis, and z-axis. Okay, and how this works is basically as x is coming towards you, this is where x is getting larger and becoming positives. Okay, so basically here x is 0, x is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would continue off this direction. And then as I push away, it's going to be negative. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, and then as I go to the right, this is not right and left. This is my y-axis. So as I go to the right, my my y values become positive. Okay, and then as I go to the left, my y values become negative. Okay, and then the last axis is the z-axis, and as I push, so if we can imagine this grid being a sheet of paper laying flat in the air, okay, it's just laying flat in the air. That's my X and Y axis. As I come off of that or below that is where the Z value, that's how the Z value is going to change. As I go up off of the sheet of paper, it's my Z value's increasing. As I go down, that's my Z value's decreasing. Okay, so that's basically how the coordinate system works. Let's actually like graph an ordered pair. So my ordered pair is negative, or not ordered pair, ordered triple. Okay, as I look at my first value, this is -2. This is 3, and this is 4. Okay, so this is X, Y, Z. So I'm looking for the ordered pair, or ordered triple, -2, 3, 4. Okay, so let's go ahead and just kind of look. So as I have -2 in the X, so that means when I'm starting at the origin here, the origin is 0, 0, 0, X is 0, Y is 0, Z is 0, right here, dead center. Okay, my -2 value is going to push me back 2. It's going to push me away 2 units. So it's going to be kind of back, like right up in here. So I'm just going to put a little hash mark there, because I haven't really gotten to my answer yet. Because I need the other ordered pairs. And it's just going to be one little dot out in space when I get my final answer. Okay, and then the next one is going to be 3. So my Y value is 3. So my Y value, I'm going to start at the origin. And I'm going to go Y value 1, Y value 2, Y value 3. Okay, so then now this can help me kind of get to my first starting point. Because I know that my ordered pair, or my ordered triple, is going to be at my Y value of 3 and my X value of -2. So basically from here, imagine this being a spot on the intersection of these two lines, being a spot on my piece of paper. So right here, the spot on this piece of paper is the ordered pair, -2, +3, Z value 0. When I'm on this paper, but my Z value isn't 0, okay, it's 4. So 4 is up. It's going to increase the value. So I just want to, for me, how I tend to do this is I need to put a point above the sheet of paper. So basically what I look is 1, 2, 3, 4. So that's probably, you know, you just kind of want to, at this point it's kind of estimating. So 1, 2, 3, 4. So I'm just going to try to move up 4 units here. So maybe something like that. Okay. And not these lines. These lines are just guides to get me to my ordered pair. But this is approximately 1, 2, 3, 4. Yeah. So you have to imagine like going straight back. That seems reasonable. Okay. So this dot here is my ordered triple. Not these lines. These lines are just here to kind of help me guide, right? Knowing that as I'm looking at my x-axis as a negative number, it's going to be behind, and Y value positive be to the right. Find that intersection spot. Once I find that intersection spot, my Z value is just going to be straight above or straight below it. Okay, and so then that's just the ordered pair. Okay, so why don't you all take a moment, see what you can do on letter A, and try it on your own. Okay, so I'm assuming that we've paused the video. You're just trying to see how you did. Okay, so let's go to X value 3. X value 3. 1, 2, 3. That's right about here. Okay, Y value -4. So -4 is going to be off to the left. So 1, 2, 3, 4. Okay, and so then now I can kind of trace these lines. 1, 2, 3, and I know it's 3 because that's my X value, and so then this intersection. So I know that my ordered triple is going to be directly above that spot or directly below that spot. Okay, my Z value is -2, so I'm going to go down approximately 2 units. Okay, and then let's just say give or take right about there. Okay, so this is kind of where my ordered triple is going to lie. And I kind of like these lines. They just help me find. Again, the lines aren't part of the ordered triple. The ordered triple's only that dot out in space. But these are just guides to help me get to where I need to go. Okay, so let's check to see how we can graph equations. Okay, and now equations are planes, just like lying out in space. They extend infinitely in all directions, but it's going to be a flat, straight plane. As if I could take that paper, float it in space, and extend it out in all directions. Anything on the paper would be a solution. Okay, before we move on to these ones, let's kind of recall back to something we did in like the first section, which is talk about just like the x-axis. So if I am lying on the x-axis exactly, what do we know about the y value? Okay, so if I think about my y values on this black line here, the x-axis, as I go to the right, 1, 2, 3, okay, so this is like increasing by 1, 1, 2, 3, and then -1, -2, -3. Well, what's that number exactly in between? Okay, well, it's 0, right? This is 1, this is -1. What's exactly in between is 0. So I know when I am on the x-axis, my y value is 0. Okay, now let's think about the z-axis. What do I know about if I'm on this line here? What's my z values? Well, my z values here would be, well, this is -1, -2, -3. This is 1, 2, 3. So what's the number exactly in between? Well, it's 0 again. Okay, so as I'm on the x-axis, I know that z is 0, and I know that y is going to be 0 as well. And this is going to be very, very important because that's going to help us figure out the x-intercepts and y-intercepts very easily. So let's just go ahead and try to find the x-intercept. So if I have this equation here and I'm trying to find the x-intercept, okay, there are two things that I know are going to be true. I know that my y value is going to be equal to 0, and my z value is going to be equal to 0. Okay, I would also suggest maybe putting a little cross through your z's, as they often will look like 2's. And so this will help me and yourself differentiate the difference between a 2 and a z. Okay, so I know that when I'm on the x-axis, or I'm looking for my x-intercept, my y value is 0 and my z value is 0, for exactly the same reason that I just talked about. So what we can do is I can just plug all these in, and then I'm left with an equation with one variable. Those I can solve. I can't solve for x here and get out a nice neat number because I have too many variables. But when I replace them in, then I'm going to be able to. So I can just say that this is 3x plus 2 times 0, okay, plus 4 times 0 is equal to 12. Okay, well, 2 times 0 is 0, and 4 times 0 is 0. So this is 3x plus 0 is equal to 12. Well, this just ends up being 3x is equal to 12. Divide by 3, divide by 3. I know that x is equal to 4. Now let's just talk about the work here. I kind of showed all of my work here, but this is going to be a problem where you're going to be able to skip through a lot of this, right? So once you kind of have this fact down and memorized, like, you can just jump to just 3x is equal to 0. You can get rid of these together because they're always going to cancel out, because anything times 0 is 0, so they're just going to go away. So what's the order triple I have? I have the order triple 4, 0, 0. So let's plot that. X is 4. 1, 2, 3, 4. Y is 0, so stay put. Z is 0, stay put. So actually, this indeed is my x-intercept. Okay, so now that I have the x-intercept, I can move on to the other variables. Okay, now, as I look for my y-intercept, I want to look for the y-intercept. So let's just think, like, when I'm looking for the x-intercept, I know that y is 0 and z is 0. So what variables are going to be 0 when you're looking for the y-intercept? Hopefully you're kind of telling yourself that you know that x is going to be equal to 0 and z is also going to be equal to 0. How come? When I'm on this y-axis, okay, I'm not moving away from the y-axis, right? So my x value is 0. Same as I'm not moving above that line either. So that means both of those values are going to be 0. So let's go ahead and work towards kind of skipping past this, because we want to work a little more efficiently than this. Although if this helps you, please do it. I would prefer accuracy. So basically what I can say is I don't have to write this anymore because I know this is going to be 0. And I don't have to write this anymore because I know this is going to be equal to 0. So my equation is just 2y is equal to 12. Okay, and then I just need to solve for y. So this looks like y is going to be equal to 6. Okay, so now I have the ordered pair 6 or 0, 6, 0. So x is 0, so I'm not going to move towards me or away from me. Y is 6, so I need to move 6 in the positive direction. 1, 2, 3, 4, 5, 6. It actually looks like it'll probably just be right here. A little off the graph, but that's not the end of the world. And then z is 0. That tells me I'm not moving up or down off of that. And that's my ordered pair. Ordered triple. Okay, last one. Let's do the z-intercept. If you haven't figured out, we will know that x is 0 and y is 0. So then that means for z is going to be equal to 12. Divide by 4. That means z is going to be equal to 3. So now I have the ordered pair 0, 0, 3. So x is 0, stay put. Y is 0, stay put. Z is 3, move up 3 units. 1, 2, 3. Okay, so now I have these 3 dots. And what we can do from this point is we can go ahead and graph them. Okay, so this is how we're going to graph them. You want to find some sort of straight edge, which you think I would have near me. I think this will work the best. Okay, and basically what you're going to do is you're just going to connect the dots. All right. And then for me, I got to kind of twist and turn it a little bit. And then here. Okay, and so really it will kind of look like a little bit of a triangle, but just imagine like a sheet of paper floating through these axes, and what it's going to do is it's going to cut through the axes at this spot, this spot, and this spot. So it's just this floating area kind of going over top of these axes here, but intersecting them at those points. Okay, and so then that there is kind of my plane lying kind of like this, shooting straight out or at like a diagonal. Okay, so what I would like you all to do now is move on to letter A and go ahead and solve letter A on your own and check your work with mine when you are done. Okay, so I am assuming that you have already tried letter A and you're looking to see how you did. Okay, so if I want to find the x-intercept, that means that I know that y and z are 0, so I can set up the equation the opposite of x is equal to 4. This I would divide by -1 to get x is equal to -4. So I have the ordered pair -4, 0, 0. So I'm going to graph that first one, then -1, -2, -3, -4. Okay, and then the next one I'm going to have is the y-intercept. Okay, and so then this one here is going to be, well, I know the x is 0 and the y is 0, so all that's left is 4y is equal to 4. And then I can divide by 4, and y is going to be equal to 1. So then this is y value 1. Okay, and then lastly, I can go ahead and find the z-intercept. And this one's going to be -2z is equal to 4. Divide by -2. And z is going to be equal to -2. Alrighty, I can go ahead and get my straight edge, whatever that may be, and just kind of connect them. So again, imagine like a floating sheet of paper out in space, cutting through at these ordered pairs, ordered triples, I mean. Okay, and so this one here is going to cut through the z-intercept at -2, the y-axis at 1, and the x-axis at -4. Okay. All right, so then now the next thing that I would like to do is I would like to show you what this will look like on a computer, or maybe just a little bit more of an accurate image of it using a 3D calculator. So let's go ahead and look here. So as you can see right here, I have my X and Y axis is my red and my green. Okay, and then the Z axis is the blue one here. Okay, so anytime you see like it's dashed, that means it's kind of like hidden below. Okay, and so what I did is I actually just drew the equation that we just did here. Okay, and so this blue sheet of paper that we have created is our plane. Now our plane is actually what we just drew on our paper. Okay, and we can see some things about it. For example, we can see that it's crossing the x-axis at -4, and as you can see, it's dashed behind, so it's kind of hidden behind my plane. Okay, and so then also it's crossing at what looks to be 1, right, about halfway between 0 and 2. And then also, where's it cross the z-axis at? Like -2, okay, which is where, you know, kind of that cutoff point is there. And so really when we're graphing these, the only part that we're seeing is the triangle created between these 3 points, our intersect at the y-axis, our intersect at the z-axis, and the intersection of the z-axis. Okay, and so that's kind of all that we're seeing between the between the 3 axes. Okay, and so then let's move on to the next one here, which I will show here in a minute. And then I'll show you also on the computer so you get a little better visual. Okay, this last one here is our, we're missing a variable. Okay, essentially when we're missing a variable, the variable is not written. That means like the coefficient, the number being multiplied by z is 0. So what that means, it's actually going to never touch that axis at all. So if I was missing the x variable, it's never going to touch the x-axis. If I was missing the y variable, it would never touch the y-path. So in some ways, it's just going to go right on past it. So if this is my z-axis, there's no z here. It's going to go right on by it. It's going to miss it completely. As opposed to if there was a z variable, it would come and it would hit it at some point. We don't know what point it would hit, but at some point it would hit it. So let's actually just do a little bit of work and we can see what that's going to look like. Okay, so I know that I just want to find the x-intercept. Okay, I know that means that z and y are going to be missing. So that means I just have x is going to be equal to 4. Right, because they would be zeros. Okay, it's still an ordered triple, even though in my equation the z variable is missing, because we're still in a coordinate system that has z in it. So we'll still graph that ordered pair. It's just going to be 0 every single time, basically. Well, I mean, depending on our x and our y's, I guess. But to find the intercept, it's still going to be 0. So I'm still going to have the ordered pair 4, 0, and then z would be 0. Let's graph that. X is 4, 1, 2, 3, 4. Y is 0, stay the same. Z is 0, stay the same. Okay, then we have to do the y-intercept. Okay, basically the same thing. We're going to find x will be 0, z will be 0, so that just leaves me with y is equal to 4. So we still have the ordered pair, 0, ordered triple, 0, 4, 0, and so x is 0, stay the same. Y is 4, 1, 2, 3, 4. Z is 0, stay the same. Okay, so then how I graph these ones is those are the only 2 points I'm going to graph, but we know that this is going to be like a plane that's going to shoot right on by the z-axis. It's never going to see it actually. So what we can do here is we can just put a little, I actually like to put a dashed line here. Okay, so we know we have a little dashed line here going through there, but then what I like to do is just try to think about a rectangle straight up and down like this, but never touching the z-axis. So that's just kind of what I sketch. You know, get a little bit of art going on here. And maybe something like this. So it's going to be like a vertical sheet of paper kind of out in space. And it never is going to actually hit that z-axis. Okay, and so you just kind of have to visualize like how is that going to move on past the z-axis in this particular problem. Now, in other ones, it might be a little bit different. So let's go ahead and we can look at what the computer has for the next one here. So I have to scroll on down to figure out my key to move past. Okay. All right, and so here is the one that we just did. Again, it's in baby blue. Okay, so we can see it's crossing through X is 4 and Y is 4 here, and that it's just going to miss it completely. It's parallel to the Z axis, and as I extend it out in any direction, it's just moving right on by it, never actually touching that axis. Okay, and so then I can actually go ahead and I'm just going to change this a few different ways so we can kind of visually see what it would look like. So for example, what if I change this, instead of Y, I change this to Z? We have no Z variable. Well, now what it's going to do, the green Y axis, it just shoots right on over top. It's going to go right through X is 4 and Z is 4, and in a line that's just going to shoot right past it, never to touch it at all. Okay, we can do the exact same thing with Y. All right, and so then Y here, now we see that it's moving right on over top of that X-axis. It's never to be touched, and this just helps us give us, honestly, a little better visual than what we can get on a piece of paper. But with the paper, we do our best to see, to give a quick visualization. All right. Otherwise, that's the end of this lesson. Just kind of the basics of what it looks like to graph in 3 dimensions and kind of what they look at. This is something that, if you go into higher level math courses, you might see some more of. But really, after today, we're just going to spend solving more algebraically than we are going to be graphing much of anything. Otherwise, it's a good time to move on to the homework for this section. And then after that, I will see you next time in 1.5.